Introduction to Differentiation. You will find this on page 255 in the Namibian AS-Level Mathematics textbook, Y equals mx plus c to success. In this video, I'm only going to focus on to show you what is differentiation all about and how we can connect this work to some of the work we already did in ordinary level. The gradient function. So first, the gradient of a line and the gradient at a point. So in ordinary level mathematics, we learned how to find the gradient of a straight line by using the following formula. So to find the gradient of that straight line, we take the difference in y values divided by the difference in x values. But that was just the gradient of a straight line. We could find the gradient of a curve, but remember, the gradient of a curve is changing. Every point on that curve, it's changing. In this case, it's going to be positive values, and then it will be 0, and then it will be negative values. So we could only find the gradient of a curve at a specific point. Okay, and let's just revise how we did it. We also learned how to find the gradient of a curve by drawing a tangent to the curve at a point, so at a specific point, and then finding the gradient of that tangent, that straight line, like we did there. So the gradient at a point on a curve is the same as the gradient of the tangent. So at that specific point there, the gradient of the straight line and the gradient of the curve at that point will be exactly the same. However, I just want to get my highlighter. However, this method only gives an estimate. Why? Because of the inaccuracy of plotting the points of a curve. Okay, so because you plot it and you draw it and there can be a few mistakes, and in drawing the tangent, because you can draw the tangent like this, or somebody can do it a little bit steeper, or so it's going to change, and that makes a difference, and that will only give them an estimate, a more or less accurate value. It is also very time consuming. So in this chapter, you will learn an accurate method. So what is differentiation all about? This is an accurate algebraic method without drawing for finding the exact gradient at any point of a curve. So there's an algebraic method, how we can use the formula and then find that gradient at that point of the curve exactly. Okay, you can click on this QR. This is very nice, and you can see a nice explanation how we can explain this, making use of the geometrist sketchpad. But I'm just going to show you more algebraically. So let's just go to the next page. Okay, so this was still part of the investigation. Okay, so let's just close this. So if I'm going to show you in algebra, and this is just making use of first principles, okay, and this is what I want to do in this video. So according to the graph, this is the graph y equals x squared. The coordinates of a and b are, okay, so this is x, and then this will be x squared, so that will be the y value. And this will be, so if I move on a little bit, so that little bit will be h, so it's x plus h, and then again, because it's x squared, it will be x plus h squared. Okay, so remember, how do we find the gradient of a straight line? It's the difference in y divided by the difference in x. So what will be the difference in y? Okay, I can maybe show you here, but it's also nicely on the curve so that you can see that. I just want to see what color will work the best. Okay, so don't forget, this is my, let's make it, this is my x1, y1. This is x2, y2. Okay, so there's my coordinate points, the two coordinate points. Do you see x? Then a little bit, x plus h, This is fx, so that is just actually what y is equal to. So remember to substitute it there. And this is then going to be fx plus h. This is my y value. So if I substitute, let's substitute in the place of y2, I can basically, okay, there I just showed you, I'm using the y values. But then I think the best if we can jump directly to this step. So I can basically say it's x plus h squared minus, what is y1? x2 divided by x plus h minus x. Okay, so we simplify. Don't forget that that bracket was squared. So square the first term, so that's x squared, plus multiply the two with each other and multiply it by 2. So that will be 2xh plus square the last term. And there is the minus x squared. Just want to get my highlighter. Okay. And then this is just bringing out, there's nothing outside the brackets, so it's just rewriting. So can you see what's going to happen in this step? This x is going to cancel with this x, and there is my h. And then I'm just going to see what cancel also. This one is cancelling this one. So I'm ending up with that part. Do you see there? Now, what I'm trying, and I think on the previous, if you were clicking on the QR, you would have seen I was trying to make this h almost 0, but I cannot divide by 0. Okay, so I was striving to 0. So that is what I'm doing. I'm making it closer at that point. I'm bringing it closer, closer, closer. So actually I want it 0. Now, in this case, look what's happening with the h, so that I actually can go and make it 0. If I go and I take a common factor out there of h, do you see? I take a common factor of h out, show you there. And if I divide, I get 2x. And if I divide, I get h. And that is exactly what is standing there over h. So what happened now? Oh, h cancel. So now it will not involve division by 0 because the h cancel. And now I can basically just go and I can, this is now my formula. Do you see? This is my formula, how I can work out that gradient. Okay, because h is now 0, don't forget. So in the previous investigation, if you were clicking on the QR, you would have seen that the x value was 2. That point there was 2. So if I go and I substitute it and I put that 2, and remember h was 0, then what did I get? 4. So if I were doing it on ordinary level, I would have get a value approximately 4, but the accurate value will be 4, and this is how we do it algebraically. So as h tends towards 0, because we want to make that space 0, b tends towards a, and the gradient of the chord AB tends to a value. We call this value the gradient of the curve at A. So what is the gradient of the curve at A? It's 4. In this case, if I was making that point A to the x value 2. So in this case, the formula for the gradient of the curve at A or any point on the curve is 2x. It's coming from there because h becomes 0. H tends to 0. This method is called differentiation from first principles. But in this chapter, you will learn some rules for differentiating functions. So we will not do it on first principles. It's also not in the syllabus, but it's just nice if you understand it if you go further in mathematics. So you do not need to be able to differentiate from first principles, but you are expected to understand that the gradient of a curve at a point is the limit of a suitable sequences of chords. So you must more just understand that principle. Okay, just note, now I want to end. The investigation made use of the curve y equals x squared. So now you can use the formula 2x to find the gradient of the curve at the point. There's the point. So what's the x value? 2, 2 and 4. Just substitute the x value of the point A into the gradient formula and you would have get that 4. If I'm going to show you the first rule in the next video, I want to use this formula that became this and actually explaining the rule by making use of what we discovered here. But that will follow in the next video.